Hey guys, welcome back. So in this video, we are continuing our wave optics and we'll be learning the polarization of the light. Okay. So before I start, what is like polarized light? Let's discuss what is unpolarized light, or you call it what normal light also. You call it polarized or just normal light, ordinary light, right? Yes. So look here. We know that what's the nature of light? Actually, nature is like a transverse wave and also EMW, the electromagnetic wave. So what happens? The electric vectors are vibrating in all directions symmetrically. So if I say like what is a unpolarized light, then how you define this? Uh, you should define like this way. So ordinary light or your unpolarized what? So in ordinary or unpolarized light, what happens? The vibrations of your electric vectors occur symmetrically in what all possible direction in a plane perpendicular to direction of the propagation of light. Suppose I represent a wave like this way. Suppose I'm saying a wave is moving in this direction. This is the direction of the your light. Okay. Let's say it's x direction. Then this is what y, and outward will be what your z, right? Like this. So if I say unpolarized light or a normal light, then what happens? The vibrations of electric field or electric vectors in all possible direction, like symmetrically, and it will be always in a plane perpendicular to what direction of light. Light is going in what x direction. This is the direction of light. Okay, x direction. I'm saying here. Okay, then the vibration of electric vector will be in all direction a plane perpendicular to what your direction of the light. Correct. So ordinary or unpolarized, the vibrations of the electric vectors, okay, occurs symmetrically in all possible direction in a plane perpendicular to our direction of the light. So yes, so these vibrations of electric vectors, they are in all direction and in a plane perpendicular to what direction of the light. Okay, yes, this is an ordinary light. Then what's a polarized light? Now what happens now? These vibrations of electric vector we restrict into a particular plane. Yes, right now is the vibrations of electric field is what in all directions, right? In a plane perpendicular to direction of the light. Now we want to restrict them into what one particular direction. Then this is called what polarization of the light. So let me define here in words. Okay, so the definition of polarized light is like this way. The phenomena of restricting the vibrations of light means electric vector into a particular direction, to a particular direction and perpendicular direction of the what propagation of light. This is called what polarization of light. Look here, unpolarized in vibration of electric vectors occurs in what all possible direction, right? Symmetrically to what direction of the light and all possible direction. Here we restrict into what one particular direction, like any one direction, you say x direction or y direction or z, right now. So this is called what polarization of light. This is like we represent how we represent what unpolarized light. Then suppose if this light is polarized, then we represent like this way. Okay, suppose first I draw this direction of the light x, this is the direction of light. Then suppose you're restricting in this direction, then polarized light we represent like this one. These arrows will be in one particular direction and always perpendicular to our direction of the light. So this is like a polarized light, correct? Okay. Now, okay, have you understood that what is unpolarized and what polarized? Unpolarized means vibrations of electric vector occurs in what all directions, and it's in a plane which is perpendicular to what direction of the light. While polarized means this vibrations of electric vector restricted into what one particular plane. Okay, yes. Now we will see that how to get a polarized light, means how to polarize a light. So we're talking about what method for getting what polarized light. Okay, many methods are there, but simplest method we use is called what? By reflection. Reflection, and this method is also called Brewster's law. Brewster's. I wrote a little wrong here. Let me correct it. I'm trying to write Brewster's law. Okay. So what happens now? As we know that if light comes from one medium, hit the boundary of another medium, then some part will be reflected, some part will be what refracted. So let's see here. Suppose this is some boundary of some medium. This is a say denser medium, and that's what a rarer medium. Anything, okay? Yes. So suppose some light beam is coming. Let's draw a normal here. This is normal, okay? And one light comes here at some angle. Let me draw light with different color. So this is your incident ray at some angle I. This is called incident ray. Clear? Then some part of this will be reflected back. This is called reflected ray, right now? RR. and some part will be refracted. It goes into other medium, that's called refracted. The refracted, right? Okay, this is called angle of refraction. This is called angle of what? Reflection, which is same as angle of incident only, right? Yes. Now what happens when this happens? Then what happens always? Some part, look here, this is your reflected ray, right now. So this ray is what? Partially polarized. We represent it like that way. This reflected ray will be partially polarized, right? Now what happens? Suppose you keep changing the angle of what? Incident. You keep changing the angle of what? Incident. Okay, so now what we're doing, suppose you keep increasing your angle of incident, then reflected ray gets even more polarized. So there is a particular angle. It's called what? Brewster's angle. What is called? Brewster's angle. So if light is incident, let's call IP is called polarizing angle. Also other name is what? Polarizing angle. Polarizing angle. So if light is incident at this angle, then what happens? Your reflected ray is what? Fully polarized. Let me write few words here. Okay. So what is your Brewster's angle or your polarizing angle? This is the angle at which the reflected light is what? Fully polarized. Let me write here clearly once more. Okay. Polarizing angle or Brewster's angle is angle of incident at which your reflected light is completely plane polarized. This light will be completely plane polarized. Look here, let me write here. If you confuse here, this is incident ray, and this ray is what? Unpolarized. This light is what? Unpolarized. So how we represent? Is there is vibrations in what? All direction, right now? That's called your unpolarized or a normal light or ordinary light, right? Then reflected light will be fully polarized. This light will be what? 100% polarized. When the angle of incident is what? IP, polarizing angle, or also called what? Brewster's angle. Then this light will be what? Partially polarized. So actually, listen here. If you want to represent a fully polarized light, okay, then how you represent? So actually, initially I had drawn the picture here. This light was some normal angle, so this was like partially polarized. Now the angle of incident is what? Polarizing angle. So the reflected light will be fully polarized. So I'm drawing a new picture here. Here you keep writing just I only. Okay, this is normal angle. Now suppose the angle of incident is what? Polarizing angle. Light is coming at angle of incident, which is equal to Brewster's angle or polarizing angle. So this angle, the light incident, this is called suppose IP. Then this is your reflected ray. This angle will be also what? IP only, right? Yes. And this is what your reflected ray, right? Now listen carefully. Once more I'm saying, suppose light is incident at IP, means polarizing angle. Then what happens? So this is a unpolarized light. This is what? Unpolarized. So vibrations are in what? All possible direction. Okay. This is a vibration. Under this condition, now what happening? Your reflected ray will be fully polarized, 100% or what? Fully polarized. Correct. Fully polarized, which is right like dot dot symbol, right? This is a fully plain polarized light, like this way. Partially, and your reflected ray, refracted. This light will be partially polarized. Partially polarized means partially polarized. We represent by this symbol dot plus like arrow in one particular direction, like this way. This is what you're partially polarized. And very interesting thing is what here, under this condition, what happens? These two rays are always what? Perpendicular. This angle between these two rays will be always what? 90-degree. I will write in next slide. Okay, let's see once more. First, this case, look here. In this picture, what happening? Light comes at any normal angle of incident, just general angle. Then what happens? The reflected light will be what? Partially polarized. This light is what? Partially polarized. Okay. Then you keep changing your angle of incident. If the angle of incident is what? Polarizing angle or is called Brewster's angle, then what happens? Your reflected ray will be fully polarized. Yes. And under that condition, what happens? Your refracted is what? Partially polarized. This is a partially polarized, and this ray will be fully polarized. Clear? Okay. Now we'll see that how we write Brewster's law. Okay. And as I said, that the angle between these two rays always what? 90-degree. Let me write here. So what happens when angle of incidence is equal to Either say polarizing angle or Brewster's angle. Polarizing angle, or you say what? Brewster's angle of incidence. Then what happens? Reflected and refracted. These two rays will be always what? Perpendicular. Will be what? Mutually perpendicular toward each other. Yes, the angle between these two rays will be what? 90 degree. Okay. Yes. Now we define what is Brewster's law. Okay. Brewster's law. So what is Brewster's law? Look here. Once more, I'm saying this is some boundary of some two medium. This is a denser medium, rarer medium. Some light came here at angle IP. It's called polarizing angle. This light will be fully polarized. We represent by dot dot symbol. Correct. This is an angle also IP, and this is what your reflected ray RR. This is what angle of refraction. So this angle is what 90 degree. Okay. Yes. Now if we want to define here what is Brewster's law. Brewster's law relate what your refractive index and what your angle of polarizing. How these two are related. Okay, for this surface, first let's write. Okay, look here. If you can see in this picture, this is normal. So this whole angle, this angle is what? Obviously 180 degree. So looking from the picture, you see from figure right now. You see angle IP, polarizing angle plus 90 degree plus your refracting angle is all equal to what? 180 degree, right? Watch carefully this one, because angle between these reflected and refracted is what? 90 degree under this condition. So from here you see that IP plus R should be equal to what? 90 degrees. Sum of these two angle, what? Angle of incident is called polarizing angle plus angle of refraction should be equal to what? 90 degree. Now we write here Snell's law. So by Snell's law, suppose you write Snell's law here, then what happens? You say that sine IP is the angle of incident, sine R should be equal to what? Mu, right? Yes, sine of angle of incident by sine of angle of refraction should be equal to what? Refractive index. Now look here from this equation, let's replace I R. R should be equal to what? 90 minus what? IP. So we replace it here, then what we'll get? Sine IP by sine R is what? Sine 90 minus IP. Okay, let's write here sine 90 minus IP, and which you'll call what? Sine IP, obviously by cos IP, right? Yes. So sine by cos become 10. So I'm writing it separately. What result we getting? And refractive index mu should be equal to what? 10 IP. This is called what? Brewster's law. So using this law, what we know, suppose you know refractive index, then you can know that at what angle the light should incident so that reflected light is fully polarized. Or you know the angle of polarizing, then you can know what? The refractive index of that medium. Correct. So this is Brewster's law. What? Refractive index is equal to 10 IP. IP is called angle of incident at which your reflected light is what? Fully polarized. Correct? IP is the angle of incident. It's called polarizing angle or Brewster's angle, right? Okay. Now see, okay, apart from the reflection light, we have some other method also by which we can get a polarized light. Like what are other method which are not much important, but I'm writing it here, other methods. So we can get by refraction also. Yes, we can get refraction method also. Yes, we can get by refraction. We also can get by like scattering of light, and we can get by double reflection also, double refraction. These all method by which you can get what? Your polarized light. We have some devices also like nickel prism, right? Nickel prism made up of like calcite material. Okay, we can get from here also. We have Polaroids. Your sunglasses are called Polaroid right now, so we can get from there also. Then uh, nickel prism, and some materials are called like tourmaline crystals. We can get from there also what? Polarization of light. Okay, so there are many ways to get what? Polarization of light. So this is not much important. Okay, now what you do? We do some questions based on what? This law. Which law? Your Brewster's law. Small question they ask in the exam, and very easy. So two things you remember here. One, that this is a law. Mu is equal to 10 IP. Then You have to remember that this reflected and reflected light, these are always what perpendicular when this light is what fully polarized, or this angle of incident is what polarizing angle, right? Okay, so let's do some questions on these. Then we move to one more law. It's called what? Malus law. Okay, the first question is like this. For a given medium, the polarizing angle is 60 degree. What will the critical angle for this medium? Take sine inverse as this value. Okay. So what is given? The polarizing angle is given. IP is given to you, right? So this is given as what? 60 degree. So if polarizing angle is given, you can find what? Refractive index of that material. So you know that by writing Brewster's law, say tan IP is equal to what? Mu. Correct. So tan 60 should be equal to mu. So you say that mu becomes what? Obviously root 3, because tan 60 is what? Root 3. It's the refractive index. Now you have to calculate what critical angle for this. So in TIR we have learned the critical angle. You say that sine critical IC should be equal to what? 1 by mu. This we have learned, right? So sine IC critical angle is 1 by root 3, and 1 by root 3 is around 0.5774. So IC we want to calculate critical angle. So it should be sine inverse of 0.5774, and this is already given in the question itself, that this is equal to what? 35 degree and 16 minutes, right? So this is what your required answer. Correct. Okay. Okay. Next question like this. A ray of light is incident on the surface of glass plate of refractive index 1.5 at polarizing angle. Okay. What is the angle of refraction, given that tan inverse of 1.5 is given 56.19 degree, right? Okay. So what is given as refractive index given, and the set is polarizing angle given, right? And we have to find what? Angle of refraction. Okay. So let's write Brewster's law here. Brewster's law said that tan IP should be equal to what? Refractive index, because they said it's a polarizing angle, right? Okay. So tan IP should be equal to what? Mu, and mu is given to us as what? 1.5. So let's find your polarizing angle. That becomes what? Tan inverse of what? 1.5. And this is already given in the question, that tan inverse 1.5 should be equal to what? 56 degree and what? 19 minutes, right? Okay, this is your angle of incident, right? Which is what? Polarizing angle. We have to calculate the angle of refraction. So here we have learned a very important concept, that when light is incident at polarizing angle, this angle is what? Polarizing. Then the angle between refracted and reflected is always what? 90 degree. Or we have learned that IP plus R should be equal to what? 90 degree, right? So here angle of polarizing we know, angle of incident at the light is fully polarized we know, we have to calculate R. So this should be 90 minus what? IP. 90 minus 56.19. This should be nearly equal to what? 33. Yes, 0.41, right? Yes, this should be equal to 33 degree and what? 41 minutes. So this is what your answer. Correct? Okay, let's move to the next question. Okay, let's see this question. So it says that a light strikes a glass plate at angle of what? 60 degree. Angle of incident given. If the reflected and refracted ray are perpendicular to each other, right? Means again the angle of incident is what? Polarizing angle. Because we know that when light is incident at polarizing angle, the reflected and refracted ray will be what? Always perpendicular to each other. Find the refractive index of the glass. So it's general formula only. So tan IP should be equal to what? Mu. This is the condition. So two ways to say, either say that angle of incident is equal to what? Polarizing angle. They will say it's polarizing angle. Or they saying another way, what? Reflected and reflected ray are what? Perpendicular to what? Each other. Right? So it's what? This condition only. We are applying Brewster's law. So tan 60 should be equal to what? Mu. So obviously mu is equal to what? Root 3. This much only the answer. Right? Okay. Let's move to next problem. So in this question is saying, when the angle of incident is what? 60 degree, the reflected light is completely polarized. Yes. The what's the velocity of the refracted ray inside the material is what? So listen carefully. Again, same question. They're saying that reflected light is completely polarized, means this angle is what? IP angle, right? Yes. This is what? Polarizing angle or Brewster's angle. So let's write tan IP should be equal to what? Mu. Brewster's law. So tan 60 should be equal to what? Mu, or mu should be equal to what? Root 3. We have to find refractive index. Now question is this, that what is the velocity of this reflected ray inside the material? So we know that mu is equal to what? speed of the light in air by speed in what medium, right? So they're asking speed in the medium. Speed in medium is what? C by what? Mu. C is 3 into 10 power 8, and mu is given root 3. So this becomes root 3 into 10 power 8 meter per second. That will be the speed inside that medium, right? Okay. So these were all questions based on what? Brewster's law. Now we have one more topic that's called Malus law. So let's learn Malus law. So actually, the Brewster's laws tell you that how to polarize the light. Then Malus law tell you that how much the intensity of light will be there after light get what polarized. So this gives a formula to calculate the intensity of light after it get polarized. So what this law says, listen here. They said when a completely polarized light incident on an analyzer. Analyzer means is some device which can either polarize the light or it can analyze, tell you how much light is polarized. Then the intensity of the emergent light varies the square of the cosine of the angle between the plane of transmission of the analyzer and the polarizer. If you're not understood, look here. Suppose some light is coming. Suppose this is a device, let's say it's Nicol prism or something. This is called a polarizer or what? Analyzer. Anything. Polarizer and analyzer are same thing. Keep in mind. Do not confuse them. Okay. Yes. So look here. Suppose some light is coming, which is what? Polarized. What is this? Polarized. It's a polarized light already, right? Yes. This polarized light is coming of some intensity I, correct? And this polarizer is placed at some angle. You call it a polarizer or angle analyzer, it doesn't make any difference, okay? So this is what the plane of this, right? Suppose making at some angle what? Theta, correct? Then after passing through suppose this intensity is what? I naught. Then after passing through this polarizer, what's intensity? So it become I naught cos square theta is proportional to what? Square of the cosine angle between what? These two axes. So look here, the intensity after passing through this becomes what? I becomes what? I naught cos square theta. This will happen, right? Listen carefully. This happens, this Malus law we write for what? Polarized light always. It's very important. Remember, it's what? Polarized light. Okay. Suppose same we have an unpolarized light is coming. This is a polarized light. So normal light is coming. Normal light means vibrations in what? All directions. This is what? Your unpolarized light. Very important. Unpolarized light coming through these polarizers. This is your polarizer. Okay, you place at any angle. Then what happens? Suppose the intensity is I naught. After passing through this light, get polarized first. Right now. Yes, and intensity here I is directly equal to what? Half of the initial intensity. This light is what? Now polarized. So two things are there to understand once more. First, Malus law we write only for a polarized light, right now? Yes, polarized light is coming. Then what's intensity after passing through this polarizer, or you call what? Analyzer, right? Okay. So listen carefully. If light is polarized, like this light polarized, and this analyzer or polarizer is placed at some angle with the transmission axis, then what's intensity after passing through this? Answer is given by what? Malus law. This is your Malus law. So what is Malus law? I'm writing here. Intensity is what? I naught cos square theta. This is called your Malus law. Clear? So this we write only for what? Polarized light. Only for what? Polarized light. Right? But sometimes they'll say that unpolarized light is coming, like this case I wrote here, right? Unpolarized light coming, then of intensity I naught passing for first time through a polarizer, then its intensity becomes what? Half I naught by 2, and this light will get now polarized. Suppose this light passes through now another analyzer or polarizer like here, then here you write what? Malus law. Here like values I naught by 2, so it becomes I naught by 2 and cos square theta. This will be answer at this point. Two case, right? Polarized light means directly you write what? Malus law. Intensity after passing through this analyzer or polarizer, both meanings are same. Do not confuse between analyzer and what? Polarizer. They are same thing only, right? Yes. So polarized light means intensity after passing through is what? Given by Malus law. That becomes I naught cos square theta. Okay. But it's unpolarized light passing through first time through a polarizer, then get polarized, and intensity is simply what? Half of this, right? This is I naught, then here becomes I naught by what? 2 only. Now this is a polarizer and is passing through another polarizer or analyzer. Then here you have to write what? Malus law to find the intensity. Okay. Yeah. So this will understand with the help of some numerical. Let's do some problem on this. Then we'll understand better. Okay. Let's see problem. So problem number one. A Polaroid is placed at 45 degrees to an incoming light of intensity I naught. Now the intensity of light that passes through up. Okay. To the Polaroid after polarization is what? So some light is there and some Polaroid is placed for this Polaroid. Okay. And correct. is place an angle. I should not drawn it rightly. Actually, this okay. Suppose light is coming at some angle of what 45 degree. Okay, this is not your eye, and this light is what suppose polarized. The notes did not say it here clearly, so we should say polarized because it's important to mention that whether incoming light is polarized or unpolarized. So we I'm assuming that is what polarized light already. So polarized light passing through polarizer means here you have to apply what Malus law. That becomes I naught cos square theta is your formula, right? So I is equal to I naught and cos square of 45. Cos is what 1 by root 2 and square. So answer becomes 1 I naught by what 2. So this means intensity is passing through this light. Sometimes they can ask you that what's intensity blocked or not passing. Then obviously the intensity that's blocked, if you want to find total intensity I naught and how much is passing I naught by 2. So blocked also what I naught by 2. So this much is what passing intensity, how much passes through after what passing through the polarizer or analyzer, and how much blocked is what this much. Okay, let's see next problem. Second question. Two polaroids P1, P2 are placed with their axes perpendicular to each other. An unpolarized, like here they said, unpolarized light of intensity I naught is incident on P1. A third Polaroid P3 is kept in between P1 and P2 such that axes make an angle of 45 degree with what P1. The intensity of transmitted light passes through P2 is what? So listen carefully. Let me draw the position. They said two polaroids are placed what perpendicular to each other. Suppose this is one polaroid. If I put one here, this is one polaroid. Let's call it P1. Then other P2 was placed perpendicular, means like that. This is your P2. And another polaroid is placed between them at some angle 45 degree with what? P1. This is P3. Angle between these two is given 45 degree. Okay. Yes. Now listen carefully. They said unpolarized light coming. This light I naught is what? Unpolarized means is intensity is variation of electric vectors in all direction. Okay. Now listen carefully. They're asking what is intensity after passing through P2 means last polarized. So okay. Look here. This is an unpolarized light. What light? Unpolarized. So we know that when unpolarized light passing through first time through a polarizer, it get polarized and intensity here in this region will be I naught by what 2. When it passes through this polarizer, first P1, intensity becomes half of the initial and this light now become polarized. It's a polarized light, keep in mind, okay? Okay. Now you want to calculate what is intensity after passing through P3. What is intensity at this point, right? So here we have to apply Malus law. Let's apply Malus law here. Malus law says that intensity after passing through this polarizer is what? Obviously I naught by 2 and cos square theta. Theta is what here? 45 degree. The angle between P1 and P3 is given what? 45 degree. So intensity at this point is what? I naught by 2, not I naught. So you have to put here properly I naught by 2 and cos square 45. So cos 45 is 1 by root 2 and square. So this answer becomes what? I naught by 4. So intensity at this point is what? I naught by 4. Correct. Okay. Now let's see. What's angle between this P3 and P2? That's also what? 45 degree. Because P1 and P2 are at 90 degree. And this angle between these two is given 45 degrees. So angle between these two also become 45 degree. So now we want to know what's intensity after passing through P2. Again, Malus law. So intensity at this point is what? I naught by 4. So I naught by 4 again cos square theta means 45. Cos 45 is again 1 by root 2 and square. So this answer becomes I naught by what? 8. So this much intensity is what? Passing through this system. Correct. I naught intensity is incident which unpolarized light. So after the light passes through these three polarites, answer becomes what? I naught by 8. Suppose they say how much is blocked? Blocked means what? I naught minus I naught by what? 8. So 7 by 8 of I naught will be what? Blocked if they ask. Correct? Okay. So let's move to the next question. Question number 3 is saying a Polaroid is making an angle of 60 degree with the electric vector. Then the intensity of light that will reduce by a factor of what? So suppose some Polaroid is there and it's placed at an angle of what 60 degree towards some incoming light. Okay. Yes. So this says I naught light. So this angle is given 60 degree with incoming electric vector. So and it's a polarized light already. So what is intensity here? I naught cos square 60. This will you answer, right? So I naught is okay. And cos 60 means 1 by 2 and square in it. So it becomes 1 by 4. So I naught by 4, this is the light what passing through the system. Then they asking this light will reduce by what factor? Correct? Na? So what is reduction here? Only 1/4 light is passing, right? So reduction is what? Reduced by what amount? It was originally I naught. Now passing is only I naught by 4. So it's 3 by 4th of light is what reduced. So what by what factor reduce? 3 by 4 I naught by original I naught. So what is the answer? 3 by 4, or you say 75%. If you want to say in percentage, you can multiply 100. This is the amount by which the light is what reduced. Means 25% light is only passing through this system. Remaining light is what blocked. Correct? Okay. Next question, question number 4. An unpolarized light is passing through the three polarites as shown in the figure. The final intensity will be what here. Okay. So three polarites are again given and some unpolarized light is coming. So let's see what happens. When this unpolarized light is coming here, I naught is unpolarized light, and this light is passing through the first polarizer, so it get polarized. So here intensity will be half of that, I naught by 2. Hope you understood this now, that when unpolarized light incident on a polarizer, then intensity directly what half I naught by 2. Okay. Now this light is a polarized light. It's a polarized, right? It's passing through this polarizer like P1, P2, and what P3. So after passing through P2, what's the intensity? We have right here Malus law. So what is Malus law here? We're writing that becomes I naught by 2 and cos square what 30. The angle between these two is what 30 degree given, right? So I naught by and cos square what 30. So cos square 30, you know, okay, square of this, right? So this become I naught by, and this become 3, and this become what 4. 4 into 2 is become what 8. So this become 3 by 8 of the I naught. So intensity at this point after passing through P2 polarizer is what 3 by 8 of I naught, right? Now next polarizer P3. So the angle between these two polarizers, what these two is, will be what obviously what 60 degree, right? Because angle between first and last, the angle here between these two is given 90 degree, and between these two 30 degree. So between these two become what obviously 60 degree. So what is intensity at this point? This becomes intensity here is what 3 by 8. So 3 by 8 of I naught and cos square 60. Cos square 60. So 3 by 8 of I naught. Cos 60 means what we know is what 1 by 2. Correct? 1 by 2, and we need here square, so it becomes 1 by 4. So 3 by, correct, becomes what 32, and what I naught. This much part of the intensity is what passing through the system. If they ask blocked, you can subtract I naught minus 3 by 32 of I naught. You can subtract that. That's your blocked intensity. Passing intensity is what this much only, right? 3 by 32 of I naught. So we have done problems on what polarizing of light means Malus law. There are two rules only. We have Brewster's law and what Malus law. So in exam, generally they ask very easy questions. Sometimes theory question also they ask like the angle between what reflected and refracted light is always what 90 degree, right now in case of polarizing. Okay. So now it's your job to solve the problem from exercise. And if you have any doubt, put in the comment. Thank you so much and have a good day. Bye bye.